Now, non-continuous graphs, when determining domain and range, I find a little bit easier because you can follow the same standard. So non-continuous graphs for like examples 1, 3, 4, 5, and 6, where those lines don't go on forever, they have definite endpoints. Okay, I find them a little bit easier to do. Number 2, I might skip number 2 and come back to it in a second, but I'm gonna do examples 1 through 6 straight away because they all follow the same pattern. When we're looking at domain is always whatever your left hand side x value, so your lowest x value is less than equal to symbol x, less than equal to symbol, and whatever your highest x value or your right hand side value is. Always, always, always. Okay? And for range, it's always your lowest point less than equal to y, less than equal to your highest point. Okay. Excuse me. So with that fresh in our head, let's have a look. Okay. Example 1. Domain and range. So here we have non-continuous graph. I know it's non-continuous because I have a definite endpoint here and a definite endpoint here. Okay. What are the coordinates of this point here? Coordinates of this point here are -3, 3. Coordinates at this point, 3, -3. Now remember, domain values are x values, which is this one and this one. Which one is our lowest? -3, less than equal to x, less than equal to, what's our highest? +3. Domain is done. X can be any values between those two and including those 2 points. And I'll talk about the open and closed dots in a moment, but let's for now just assume that all the dots that we're dealing with, and they are all dealing with, they're all closed dots. Open dots mean something different. Range values, let's change colors. Range values are the y values, so those two, 3 and -3. And again, it says what's our lowest y value? -3, less than equal to y, less than equal to positive, our highest y value, 3. So domain, left hand side, right hand side, range, lowest, highest, separated by similar information. Always, 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 always. Let's look at number 2. Or no, let's skip number 2 for now. Let's look at number 3. Okay. Number 3, again, it's continuous endpoints. Okay. We look at our highest x value, so let's look at the coordinates of our endpoints. So in this case, it's going to be 1 and 5, and in this case down here, it's going to be 1 and -5. Well, that's curious. Both our highest and lowest value are exactly the same. In this case, x can only equal 1. Okay? So these vertical lines or the horizontal lines are like oddballs, as well as example number 2 where we have individual dots. So here, because we have a vertical line, x can only be 1. Okay? What about our range? Well, our range goes from our lowest point, -5, to our highest point, 5. -5, less than equal to y, less than equal to +5. And done. Number 4. Number 4. I'll split this video into 2 videos. We'll do 4 and 5, and then I'll come back and do 6 and number 2. Okay. So we have endpoints, non-continuous. Coordinates of our endpoints are -4, 2, and 4, -2. X values or range or domain values, X symbols. I can do my range right now too because I know it's going to be different. What's my left hand side X value? -4. What's my right hand side X value? 4. What's my lowest y value? -2. What's my highest y value? 2. Domain and range. Done. Number 5. Number 5. Again, endpoints, coordinates, -3, -3, and 3, -3. For my domain, is my x values. I have -3 as my left-hand side. I have 3 as my right-hand side. My range values, my y values, I have, oh, well, let's have a quick look. We got a problem there, don't we? Because these are exactly the same, but we don't have a horizontal or vertical line. So let's look to see, okay, so our lowest one is -3, but we can have some higher values. We can have -2, we can have -1, and we can have 0. So it goes as high as 0, right? Y up to 0. Okay. So you do have to be a little bit careful. The format's always the same, but you have to be a little bit careful in filling it in. Okay, so I'm going to stop this video here to keep it nice and short. When I come back, I'm going to do example number 2 and example number 6, and then talk to you a little bit about some open circle graphs as well as some notations that you might see.